Hello everyone and welcome to this new project. In this project, we are going to learn how to deploy a machine learning model or an AI model using TensorFlow serving. So this project is going to be very interesting. That will be the first step into how to take our models that we train beforehand, throughout the entire course. It's a little bit step further and actually start to deploy it in practice. So we're going to take that model, that trained model, we're going to run it on a server, and then we'll start to make requests to that server and try to get feedback. So we're going to send an image to a server, and then the server we're going to reply back and tell me what class that image belonged to, which is, again, that's pretty incredible, because that would be kind of the foundation if you want to build an app, if you want to make a startup, if you want to do whatever. This is kind of the basics or the foundation of how to take AI or trained AI models a step further. All right, so let's get started. First, we are going to use the fashion data sets that we have done beforehand. So we're going to in the first couple of steps, we're going to learn how to train our model and build our model. And that will be pretty much as we have done in the previous lectures. That's why I will go through them a little bit faster. And then afterwards, in the next section, I'm going to show you how to actually save our model and how to save different versions of the model, and then how to deploy that model using TensorFlow 2.0 serving. So again, in this project, we're going to build, train, and test a model to classify fashion images using TensorFlow 2.0, which is similar to the steps that we have done in the past. And what's new is that we're going to deploy that model in practice using TensorFlow 2.0 serving. So again, if you guys recall, our fashion data set consists of 70,000 images, and they are divided into 60,000 for training and 10,000 for testing. And the data set consists of images that are 28 pixels by 28 pixels, and all of them were grayscale images. And we had 10 classes. And if you guys remember, these are the classes. We had class 0, that belongs to a t-shirt, class 1, a trouser, 2, pullover, 3, dress, 4, coat, sandal, shirt, sneaker, bag, and ankle boot. Each image consists of a 28 pixel by 28 pixel, and the total is 784 pixels in total. All right. And again, all the numbers of these pixels range from 0 to 255. Again, all these are basics. Please, if you are a little bit confused, please go back to earlier sections of the course, and you should find a ton of details regarding the images, how to represent images digitally, and so on. All right. Please note that this section of the course, you will find of the project, you will find that some of the code sections are based upon the TensorFlow 2.0 documentation, and here is the link to the documentation of the TensorFlow 2.0 serving. So first, let's go ahead and import our packages as usual, and then afterwards we are going to import our dataset. So here we went to tf.keras.dataset, fashion mnest, we loaded the data, and here we have xtrain, ytrain, xtest, and ytest. Pretty simple. And then we normalize the data. So we divide by 255, so we normalize it. And then we checked out the shape. So now I have 60,000 images, each is 28 by 28. That's for xtrain. For xtest, we have 10,000 images, each is 28 by 28. And what we're going to do here is that we're going to reshape our training data to be in form of 60,000, 28, 28, and 1, which is what we call it batch format, instead of 60,000, 28 by 28. And then, again, that would be very beneficial when we actually build our model. So that's how we reshape it. So I'm going to say xtrain.reshape 0, which is basically 60,000. And here we're going to reshape the pixels, make it in a form of 28 pixels by 28 pixels by 1. Okay. And then afterwards we check out the shape. So now beforehand it was 60,000, 28 by 28. Now I have 60,000, 28 by 28 by 1. And then we're going to do the same for the testing data. So we reshape the testing data in the same fashion, and we check out the shape, and now we have 10,000 images, each is 28 by 28 by 1. Let's go ahead and check out the classes. So here are the list of classes. So we created a list, and within that list, we created basically a bunch of strings in here of the different classes, so we can basically print them out moving forward. We check out the length of the xtrain, again 60,000. And what I'm going to do here is I'm going to create a grid, and within that grid, we're going to print basically 16 images, 4 rows by 4 columns, and we're going to visualize, just we're going to plot the image along with their training label. So, or my desired label, my apologies. So here I'm going to pick a random number. That random number ranges from 0 up till n training. So between 0 and 60,000. And that will be my index. And every time I'm going to say, you know what, go ahead and plot or use image show. We're going to show our X train, our image. We're going to pass along our index here. And then we're going to show its true label. So I'm going to say Y train. I'm going to pass along my index too. So here I plot the image. It's again, it's a bag, class 8. Here it's a shoe, class 9. It's a bag, class 8, and so on. And these are the different, basically, input-output data. So that's my input data, my image, and that's my output. That's my desired output. That's what I want the model to be able to give me after training. All right, let's go ahead and build, train, and test our model. So first, we are going to use Keras to build our model. And as I mentioned, Keras is the default API when it comes to building and training artificial neural networks in TensorFlow 2.0. So here we say tf.keras.models.sequential. We have done that so many times. And then we build the first layer, which is convolution layer, has 32 filters, each is 33 by 3. The activation is ReLU, and the input shape here is 28 by 28 by 1. And then we added max pooling. Again, the idea is to try to compress the image or feature maps, try to reduce the size. Another convolution again with activation of ReLU, and then we flatten it up, and then we add a bunch of dense networks or dense layers. So we had the dense layer of 64 neurons, another dense layer, and that's the output layer. It has 10 neurons because I have 10 classes, and here we have our softmax function. All right, looks good. And here we have 500,000 parameters to train. Again, pretty incredible. Afterwards, we're going to specify how many epochs. So we specify we're going to run for 5 epochs, and we're going to compile our model. So that's how we compile our model. So here we select tf.train.atom optimizer, and then we specify our loss, which is going to be sparse, categorical, cross entropy, and our metrics will going to be our accuracy. So let's run that. So that's how we compile the model. And then here we're going to use the fit method on my model, and we're going to pass along my X train, Y train, and the epochs as well. So let's run that. And then after we train it, actually, we're going to evaluate the model as well. So here we're going to take our train model. We're going to use the evaluate method on my train model and pass along our testing data. And here we go. The model is already at 85% accuracy. Again, pretty incredible given in just one epoch. Now it jumped to 90% accuracy, and it's getting better and better over time. All right, looks good. So that's my second epoch. Again, we have done that before. That's why I'm going through it really quick. Here we have 92% accuracy. And then we should reach, I hope, 96%, I hope. So 93 right now. Epoch 4. And it's going up. Hopefully we'll reach 96. Probably we're going to stop at 94, maybe 95. So 95, great. Okay, I hope it's getting better. So again, within only 5 epochs, we have been able to achieve around 95% accuracy on training, and we have been able, on testing, we have been able to reach almost 91% accuracy on the testing data set, and that's pretty good. All right, okay, that's all what I have for this lecture. I hope you guys enjoyed it, and that's basically here. We haven't discussed anything new yet. All that is just the basics, the basic foundations. Now we train the model. In the next lecture, we're going to learn how to save our model and how to start to deploy our model on the server using TensorFlow 2.0 serving. And that's all what I have for this lecture. I hope you guys enjoyed it. And please enjoy TensorFlow 2.0 and happy learning. Hello everyone and welcome to this new lecture. I'm getting super excited because in this lecture, we're going to learn how to save our model and how to deploy our model using TensorFlow 2.0 serving. So if you guys recall from previous lecture, we took a model, we trained it, we fit it with the training data, and now we have all the knowledge, all the learnings, all the trained weights are captured within that object, which is CNN object. All right. So first, we now need to save our trained model, and it has to be saved in what we call it in a saved model format. So the model will have a certain version number, and that version number will be saved in a structured directory. So what's important to be noted here is that we want, when we train AI models in general and we deploy them in practice, we generally, all these models, we have different versions of them. Why? Because again, they are not mature yet. They are continuously learning. As we acquire data from the customers, as these models are being trained, all that training data is being fed back to the model to update the weights. So now we have version 1, and then version 2, and then version 3, and maybe these models are deployed across different, let's say, regions. We have models, let's say, deployed, for example, let's say in Brazil. We have another models deployed in, let's say, in Egypt, for example, and then some in Canada or whatever. So that's why we have different versions of the models. So you have to keep track of these different versions and maybe name them as well. So what you could do is, to save the model, is you're going to say tf.saved_model.simple_save, and this is a function that can be used to build a saved model that is suitable for serving using TensorFlow Server. So if you actually just apply simple save, that should save the model and should save it in a special structure that we can use afterwards, TensorFlow serving, to be able to deploy our model afterwards. So after the model is saved, we can now use TensorFlow serving to start making inference requests. Basically, send that model an image and the model will respond back. But we're not going to do that locally though. We're not going to be doing this, let's say, on my computer, for example. We're going to be doing this while running the model on a server. And that's kind of the new part here, the new element here. So what I need to do is I need to specify what's my trained model is called, which is what we call it servable. So the trained model now is called servable, and now I have to specify or give it a certain version number, what version of that model I want it to run. So what happened is that saved model we're going to be able to save and load our models. So when we say the model, that means we're talking about variables, we're talking about all the graph, all the structure of my models, and all the metadata contained within our model. So basically every single information, every single trained weights, all the architecture of the models, how many neurons, which neurons are connected to what, and so on. All that will be captured when we run the simple save function. And then what's really good about it as well is that it's what we call it language neutral. It's recoverable, which means that I don't need to save the model with different formats, for example. What's good about TensorFlow serving is that if you use simple save, it will just save it in a certain structure that can be language neutral. Then I can call it easily using TensorFlow serving, and I'm going to show you that, guys, in the next couple of lectures. So let's see how can we use simple save. So first we're going to say simple save. We have to specify which session am I referring to. I have to specify what's my directory we're going to be. So we're going to save it in a certain directory. And I have to specify what's my inputs, what are my inputs, and what's my outputs. That's all what it is. It makes sense. I need to specify, again, my directory, where I'm going to be saving that model, what's my inputs, and what's my outputs. That's all what it is. And if you guys want to get more information, please go ahead to tensorflow.org guide and then save model to this link. All right, so let's get started. First, we're going to obtain a temporary storage directory. So we're going to say model directory, you can call it whatever you want, equal temp file.get temp directory. And temp file, if you guys recall, we actually imported it beforehand. So here we went up there, we imported temp file. Okay, so that's the first step. So we imported beforehand. Now we can use it. And then afterwards we can say, okay, show me my model directory. So it will tell me, okay, now I have a temporary location, a temporary directory called temp, TMP. And then we need to specify the version number. So we're going to say my version of the model is going to be equals to 1. So my version equals to 1. Looks good. And now I was just going to concatenate, just mix up my model directory, which is temp. I'm going to add backslash. I'm going to add my version number. So to do that, I'm going to say os.path.join. I'm going to specify my model directory, which is what we have here, which is a temp. And then I'm going to take my version number, convert it to a string format, so a string of 1, so now it's a string, join them together, and that will be my export path. That will be my that's where I want to save my model. So, and now I'll be able to print basically my export path, which is going to be export path equals 2, and that will be /temp/1, and that's basically the directory we're going to be saving my model. So let's go ahead and save it. It's actually pretty simple, pretty straightforward. So we're going to say, let's save my model. So we're going to say if os.path.isDirectory of export path. So basically I'm asking if the model, does that path exist beforehand or not? If it already exists, then I'm going to say, okay, already saved the model. So my model is already saved. Let's clean it up. So I'm going to say go ahead and remove. So exclamation mark RM stands for remove. So I'm going to remove basically that directory. And basically afterwards, so I'm going to say tf.savedModel _ simple save. And that should basically save my session. So I'm going to save, first of all, get my session. And then I'm going to specify what's my export path going to look like. And then I'm going to specify my inputs and my outputs. So my input here will be my cnn.input. And then my outputs, because I have multiple outputs, so I'm going to say create a list comprehension. So I'm going to say for I in cnn.outputs, every time I'm going to go call it I.name with I. Or it's kind of, like when I run it, you guys will going to understand what I'm talking about. So when I run that, okay, looks good. And when I list it, here we go. So now I have been able to basically save my model, and my saved model will be saved _ model.pb. That's basically where all the intelligence have been captured already and has been saved. And please bear in mind that now we have a model, and that model basically is saved in that specific path, which is temp _1. Let's take a look at it. So I'm gonna say go to my files, go up here, and then go to my temp. You should find the temp here. Go to 1, and here we go. So now I have my saved model.pb, and I have my variables as well. All right, okay, and that's all what I have for this lecture. I hope you guys enjoyed it. In the next lecture, we're going to explore our saved model, and then we're gonna start serving our model using TensorFlow serving. Please enjoy TensorFlow 2.0 and happy learning. Hello everyone, and welcome to this new lecture. In this lecture, we're going to explore our saved model, and then we're going to learn how to serve our model using TensorFlow serving. You will find some code here that doesn't make much sense, okay? But again, all the code lines in here, they are pretty much standard. So if you actually use them and deploy it with whatever model you have, you should have no problem at all. What you need to do basically is, if you're going to train, let's say, an algorithm to, let's say, classify for example, like Cypher 10 data set, or let's say classify like smiling faces, or classify whatever new data set, what you need to do is just here, when you save the model, you just wanted to basically specify what's my directory will gonna look like here, okay, what's my path will gonna look like, and you need to just train the model, basically all the steps that we have done beforehand, and you need to save it, and what's coming is pretty much the same, consistent across every single basically step. So here we said save my model. I need to specify what's my object, which is CNN, inputs and CNN.outputs, and that's where all the maybe the differences might happen. Moving forward, pretty much we're going to be pretty much the same. So what I could do here is again explore our saved model. So what I could do, again, I run that. We're going to say exclamation mark saved _ model _ CLI. So saved _ model _ CLI will be used to explore what we call it metagraph defs and signature defs. Basically, I need to know what is my model, and I need to know what's the methods that I can apply to my model. So basically, when I say metagraph defs, that's basically my train model, all my train weights and so on. And here, all the methods that I can apply to it. Let's say I wanted to apply the predict method, for example, to make predictions based on my train model. And basically what a metagraph contains, it contains all the data flow graph, all the actual architecture of the model, all the associated variables, and all the assets as well. So let's run that. So here I'm going to say, okay, go to my saved _ model CLI, show. I need to specify my directory. So because here my export path is basically what I have here, which is a directory of my model, which is temp _ version 1. My apologies, / version 1. That should show me my architecture basically of the model. So as you guys can see here, you will find that here the shape of the input is 28 by 28 by 1, and that makes sense because I know that my model has been trained on the fashion MNIST dataset, which is again pretty good, because if you have any saved model and you don't know, okay, I don't know, like, you know, who someone, for example, from a different team trained it, and you want to know what's the dimensions of the inputs and the outputs and so on, you can just run this command that will show you basically the architecture of the model. Just the inputs and outputs from a very high level, which is again pretty good. Here it will tell you the output shape is 10, so I know that I have 10 samples, and the actual output is a softmax output or activation functions, which again makes sense. All right, let's go ahead and actually serve our model using TensorFlow 2.0 serving. So first, we're going to add our TensorFlow model server package to our list of packages. So here we just wanted these kind of lines of code. Again, they look a little bit strange, but simply what we're doing here is that we're trying to install TensorFlow model server package. That's all what it is. These are the 2 lines of code. So if you run it, so we're going to install it, and then we're going to update it as well to have the most up-to-date version. So we are running it here, and that should just install our model server package, and that will be the first step. Okay. The next step is that we're going to install our TensorFlow model server. So we're going to say get install TensorFlow model server. So that should install my server. And then after I install the server, I should be able to actually run my TensorFlow serving on the server. So what I'm going to do here, I'm going to say, okay, to run the TensorFlow serving, what I need to specify what's my port going to look like, what's my port number. I need to specify what's my model name. I need to give it a name, okay? And I need to specify what's my model base path, what will gonna be my path to my model. If you guys recall from previous lectures, is that we saved our model already in that export path. If you guys remember, here we had our temp, \temp\1, if you guys remember. So after we do that, here what we need to do is that we are going to say that's my model directory. That's where I actually save my model. And what I could do here, I'm going to say, okay, run my model server. I need to specify what's my port number. So here my port number is 8501. I need to give it a name. So here I called it fashion MNIST model. You can call it whatever you want. And then here I need to specify what's my path of my model we're going to look like, which is simply our model directory, if you guys recall beforehand. So if I run that, it's telling me looks good. So job 0 has started. That's a good thing. That's mean the server is running. All right. So let's go ahead and run our server. So first we need to specify our port. So here we're going to specify our port number will be 8501. Here I need to specify the model name. So here I called it fashion_model. You can call it whatever you want. And then here I need to specify my model base path. And here my model base path, which is model directory, which is what I specified before as temp\1. If you guys recall, we had our directory here, which is export path temp1, if you guys remember. So let's go ahead and run that. So we run that first, then we run that second. It's telling you starting the job number 5 in a separate thread. And if we take a look at the log, it will tell me that everything looks good. So the model has been successfully, if you check out here, successfully loaded servable version, which is again, that's very good. So now we loaded the model. We know that the model version is 1, and now the model is running on the server. Again, this is a huge, amazing accomplishment. Again, it's very, very simple, but now we are actually having an actual AI model running on the server, and now we're pretty much ready to send the request to that server and get feedback from it. Again, pretty incredible. So let's go ahead and start making requests using TensorFlow serving. So first, I'm going to create a function. That function is called show. It basically just plots our actual index here, plots an actual image first, and then on the title, it will show me the actual, I need to show the actual image, the actual label, true label for it, along with the actual label. For example, let me show an example. So here, for example, we selected a random number from my testing data. And then here we show me my index, my actual image, along with the actual label. So I'm going to say an example image is, let's say, sandal, for example. So here I relied on the class names, which is simply my translator. If you guys remember, we had here our class names here. This is our class names, if you guys remember. So here I'm just going there with the index, just saying, okay, show me, it is the shirt, is it a sneaker, is it a bag, is it whatever, and that's how you do it here. All right. Let's go down, 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 down. All right, looks good. And this is the most important part because now we're pretty much ready to send a request. Okay, so first I'm going to create what we call a JSON object, and what I'm going to do here, they're going to make 3 inference requests. So if I run this cell, basically here I created a data, and that data consists of 3 samples of the image. I need xtest. I'm just going to select 3 samples. So from 0, 1, and 2, so I selected 3 images. And now I'm going to pip install queue requests, and I'm going to import requests, and this basically we're going to enable me to start making server requests. So let's see how can we make an actual server request. So first here we're going to make a request. I'm going to specify the header, so I'm going to say my content type. Here I'm going to specify my application and then JSON. Afterwards I'm going to say, okay, let's make a request to my server, but to make a request I need to specify what's my port number will look like, which model I'm going to be running, which version am I talking about, and what's the name of the model, and then I'm going to pass along my data. That's all what it is. So I'm going to say requests.post, and that's how you actually create a request. And then I'm going to say HTTP. I'm going to specify my local host, and that will be my 8501, which if you guys recall, 8501, that was my port number when I actually defined my server here, 8501. The name of the model was called fashion model, if you guys recall as well. So here I'm going to specify, first of all, my version, which is going to be version 1. And then I'm going to specify models. I'm going to call this exact same name, so that will be my fashion underscore model. And then I'm going to specify colon, and then I'm going to specify my method of calling that model. What methods I'm going to be referring to. And here I'm going to use a predict method to basically make predictions based on my model. And then I'm going to specify my data. So here I passed along my data. If you guys remember, that was my data that basically contains all the images here, if you guys remember. And then I'm going to specify my headers, which is what I specified here, basically. So here I'm going to make a request to the server. The server will respond back, will give me the JSON response. And then here, think of it as kind of a decoder. It just decodes the message that's coming from the server, and that would be my predictions. That would be technically my output. So let's run that. Now I got predictions from the server. So let's go ahead and decode my predictions, and here we go. Amazing. So now I plotted my image, and then I plotted what I got from my server, which is my predictions. So here I said, go ahead to my predictions, obtain my argmax. If you guys remember, I had a softmax function at the output layer. So now I need to see which one has the highest probability of occurrence. And I'm going to go into my class names, and then I'm going to specify which one am I referring to out of the 10 classes that I have. So here I said the model thought that it was an ankle boot class 9, and it was actually an ankle boot. Again, this is incredible. Now I'm actually running an actual AI model on the server, giving it a request or sending it a request and getting feedback, and I'm being able to decode my feedback as well. So what we're going to do here, we're going to do the same thing as well, but I'm going to call the server basically 3 times. I'm just going to call the server and make predictions, and then I'm going to create a for loop that can plot my images along with my server feedback, along with my true label as well. So when I run that, and here we go, you will find that here basically I got 3 images because I sent out the data contained 3 images. I got 3 back 3 requests, and I've been able to create a for loop. Every time I'm going to plot my predictions of whatever index along with my actual Y label, which along with the actual true class. So here the model thought that was an ankle boot class 9, and it was actually an ankle boot. That's good. The model thought it was a pullover class 2, and it was actually a pullover. That's great too. The model was trouser class 1, and it was actually trouser. That means my model is performing great, performing perfectly. And that's it. That's all what I have for this project. I hope you guys enjoyed it. Please enjoy TensorFlow 2.0 and happy learning.